You are welcome to this channel. In this channel, we'll be talking about basic mechanics, the basics of all mechanics. And then I am very much excited to start my journey with you. So without wasting much time, let's get started into the lessons for today. So basic mechanics, this is the introduction part. In the subsequent videos, I'll do more tutorial sessions and then upload it here so that you can have access to it. So what is a force? See, a force can be defined as the cause of change in the state of motion of a particle or a body. That is, a force causes an object to change its position or state of rest. Let's take for example, if you have a book lying somewhere, let's say I have this book here, pardon the drawing. I have this book here, right? This book is lying down and there is no influence on it. So for me to get the book to move from, let's say, position 1 to position 2, then I have to apply a force. Then that force will be capable of dragging the book from this position to, let's say, another position, which is here. So that's why we see that a force can be defined as the cause of change in the state of motion of a particle or a body. Initially, the position of the book was at this state 1 here, right? At this state 1. And then we apply the force to it to change its state of motion or position to this state 2. So in that case, we say that we have applied a force. Another example, let's say it's not just to books or non-living thing, even humans. When we move from one place to another, that movement is only possible because we have applied force. So anything at all that is able to cause an object to change its position from one state to another state, we can say that a particular thing is a force. Another scenario, let's assume we have a vehicle. Yes, this is the vehicle here. It's at a state 1 state. That's the position is initially at 1, and then it moves from this position. Let's say it goes through this direction, okay, and it comes to another position. Let's say position 2 here. Position 2. What it means is that we have been able to apply a certain force. We have been able to cause the object, which is the car or the vehicle, to move from this state 1 to this state 2. In that case, we can confidently say that a force has been applied. Okay, so in general or in all, if I'm able to cause an object from one position or one state to another state or position, then I have caused or I have applied a force which has been capable or which is capable or which has been able to move the object from that particular state to a different state. So without forces, an object in a state of rest or which is static will continue to be static. It's the same way without forces, an object in a state of motion will continue to be a motion. So if I'm able to apply some kind of force which is able to cause an object to stop, or it is able to cause that object to start a motion, then we can confidently say a force has been applied. So basically, a force is said to be what? To cause a change of state of emotion of a particle or a body. So if you cause the motion of anything at all to change, whether from rest to movement or from movement to rest, we say that a force has been applied. So a force is giving us F is equal to ma. That is, force is the product of mass times acceleration. Let me write it again for you. Force is equal to mass times acceleration. So for a force to actually, that's the when you multiply the mass of a body, okay, the mass of a body times its acceleration, it gives you the force which has been applied. So in mechanics, or let's say with matters related to forces, Newton proposed, or this is a Newton formula. Yes. So a force is said to be the product of mass times acceleration. When you have a mass, you multiply by the acceleration, you get a force. So as time goes on, I will say we will talk more about forces, and then we will get ourselves familiarized, or we familiarize ourselves with some of these concepts. Okay. Now the characteristics of forces. You see, forces, as in the previous slide was shown, you say that it causes an object to change its state of motion. And these forces, they normally come with some kind of characteristics. That is, they have special features that makes them, or let's say a force has special characteristic that makes it a force. So what are those characteristics that makes a force a force? Don't get yourself confused. So what is a force and what makes a force a force? So we say a force is a vector quantity. When we say a force is a vector quantity, then we are talking about one. We are saying it has a vector quantity, means it has magnitude and it also has direction. So these two points, that is the magnitude and direction, makes it a vector quantity. Like this. Yes. So a force has both magnitude and direction. But in other characteristics, we can also say it has a point of application and also a line of action. So I will describe all these characteristics in a simple image as this one. Okay. So let's assume this simple scenario. We have a rectangular object here, and then we have, let's assume this line, this particular line here, that is this particular line here, and then this particular line, they are the lines of action. Remember, we said the force has 1, magnitude, 2, direction, 3, point of application, and 4, line of action. So the characteristic: 1, magnitude, 2, direction, 3, point of application, and 4, line of action. So when we look at this image here, we realize that, let's talk about 1, the magnitude. So the magnitude in this particular example, the magnitude is represented by the arrow here, which is the arrow here, right? So assume that the arrow is drawn to scale. The one here is not drawn to scale, but let's assume that the arrow is drawn to scale. Then what it means is that if we draw a line, let's say we have this line here, to be 20 newtons, then we want 40 newtons. 40 newtons will be somehow twice the initial one. So we can say that that is the magnitude. When we say magnitude, then we are talking about let's say the quantity of it. Yes, in other words, you can say the quantity of that force or the effect of that force. So every force has a magnitude. So the magnitude will tell you whether the force that is being applied is huge or it is small. So if the applied magnitude is huge, or if you say that if the quantity is too much, we say it has a high magnitude. Then if it is small, we can say it has a low magnitude. Okay, so that is one characteristics of a force. It has magnitude. Then the second one, it has direction. Direction. Mostly when it comes to force representation, the arrowhead shows the direction in which the force is being applied. So in these two examples here, that's the 20 Newton magnitude and the 40 Newton magnitude, we can say the direction of these forces is towards the right. So it means that the particular force here is moving from left to right. That is the direction of that force. And in another example, let's say I have it this way. If I had them this way, then this also shows a different direction, that is from the right to the left. So forces are characterized by one, their magnitude, and two, their direction. You see, this direction, that is the 20 Newton magnitude and the 40 Newton magnitude, they are assumed for this particular illustration, they are shown to be on the horizontal direction. However, forces are not only um, applied in horizontal directions or vertical direction, they can be applied in any angle at all. So the angle in which it is being applied describes the direction of the force. For example, in this diagram here, we have the magnitude 20 moving horizontally. So we can assume, we can say this one is either on the 0 degrees, or yes, it's 0 degrees or 180 degrees because it's horizontal, right? However, assume that instead of being applied horizontally, it is applied vertically. If it's applied vertically in this manner, then we can say, or let's see, let me use the diagram here. Assuming the force is applied vertically here, then it means that we have a direction at 90 degrees or 270 degrees. Okay. In another scenario, it might not be like this. It might be at an angle. It might act along this particular line of action here, which will make it, let's say the angle here is 45 degrees. So forces can act in various directions. It doesn't matter. It can act in various directions. So one characteristic, you don't forget, forces have one, magnitude, two, direction. Okay. Okay, so we have explained what the magnitude means and then what the direction means. So let's go to the next point, which is the point of application. That's the three, the point of application. When we say point of application, then we are talking about the exact location the force was applied. Okay, so taking this image for illustration, we realize we are talking about the points of application here. So with the points of application, let's say let's take this 20 Newton force here. This 20 Newton force here. Okay. The point of application is here. So where the arrowhead points to on the figure here, that is the point of application. The arrowhead touches, or it's pointed towards this part. Let me change there. It's shown here. So that part becomes the point of application. This part becomes the point of application. So where the arrowhead is actually directed towards, that becomes the point of application. Then in another example, assuming instead of this side, the force was directed here. then this point becomes the point of application. In another example, it might be directed at an angle. Let's see here. Then we can show it here. So that part becomes the point of application. So the point of application, forces, they are not just applied. When you apply forces, they have specific places that they are directed towards, and one of them is this. That is what we call the point of application. Okay, so any direction, it has one. We say forces has one magnitude, two direction, the point of application. So this is the point of application where it is directed towards. That's the point of application. Then the last one we'll be talking about for the characteristics is the line of action. So line of action, what is the line of action of a force? The line of action of a force is the imaginary path. Let's say it's the imaginary path that the force passes or the force uses. It's an imaginary path that the force uses. So let me draw the rectangle again here. Okay, assume we have this, and then this is this is a rectangular object, and I apply a force this way. So one, with drawing the arrow, I'm able to tell one I'm able to show the magnitude, I'm able to show the direction, I'm also able to show the point of application of the force. Okay, the next thing we will talk about, after knowing the point of application, that's the line of action, to what imaginary line is the force acting towards, or what imaginary path that the force take. So this, let me draw these dotted lines here. Okay, so this dotted lines here becomes the line of application of the force. So that imaginary path that the force is taking, the imaginary part the force is taking becomes the line of application of the force. In another example, assuming I have a force acting this way at an angle here. So if I draw dotted lines through this path, okay, it's the line of application is somehow infinite. So it's infinite. Okay, so this path, that's this imaginary path that the force takes, is described as the line of application of the force. So one, we know a force has magnitude. Two, a force has direction. Three, it has the point of application. And then four, it has the line of action. So this one here, it shows one line of action, another line of action here, and another line of action here. One may wonder, so how do I know the line of action of a force? It's very simple. If I draw an arrow like this, sorry, let me draw it better. If I draw an arrow like this, I know this length here from here to here describes the magnitude. This arrow here shows the direction, right? The arrowhead shows the direction, and then the point of application where the arrowhead ends, this is the point of application, and then the line of action is an imaginary line through this line. So anywhere, anyhow the arrow is positioned, if you draw imaginary dotted lines or through that arrowhead, you get your line of action. That is the imaginary path that the force takes. Okay, then we will talk about system of forces. What are system of forces? When a system has more than one force, acting, it is known as a force system or system of forces. Mostly in real life applications, we do not get a single force acting towards a single body. It's almost not possible to have such scenario because always and always there are more than one forces acting on a particular object. For instance, if I have an object like this, there are forces acting on this. Let's say this is a surface. Let's say it is lying on a surface, right? The object is lying on the surface. As long as it is lying on the surface, the force, it has weight which is acting downwards, and it has reaction forces which are also acting upwards. Amongst other examples, where you might have a simple system that you have just one force acting on it, but however there may be some reaction forces in other way. They may be negligible, or if not negligible, then very very huge. Yes. So as I was saying, when a system has more than one force is acting, it is known as system of forces or a force system. So let's say I have this shape here, this same rectangle here. I have one force acting this way, then I have another force acting that way. This gives me a system of forces because I have one force here, I have another force here. There are also situations that I might get another force acting this way, right? Okay, so what are some of the kinds of the force system? We will look at a few of the force system, and the first one we are looking at is collinear force systems. So what are collinear force systems? We say the lines of action of all the forces of a system act along the same line. They act along the same line. So the line of action, remember we said the characteristics of forces, they have lines of action. They have one direct, that's the lines of action here. Lines of action is one of the characteristics of forces. And now we are saying that for collinear force systems, those lines of action of all the forces of a system act along the same line. So what does it say? What does it mean? This is what it means. This is what it means. So assuming that I have, let me change the color. Assume I have this shape here, this shape here, and then let me draw this imaginary line here. So this imaginary line, let's assume that is the line of action, right? That is the line of action. Then we say for collinear force system, all the forces of the system act along the same line. So I may have one force acting this way. Let me change the color for that one. So I may have one force acting this way. So you realize that this line, this force, it has this line of action. That is another force. Let's say the force has a magnitude of 5 Newton. And then I also have another force acting this way. Along that same line of action, there is another force acting in the opposite direction. Let me see, this force has a magnitude of 15, or let's say 7 newtons, right? So you realize if I should draw an imaginary dot or an imaginary line of action through this particular 5 Newton force, it's going to have the same line of action, the same dot passing through here. And for the 7 Newton action, the same imaginary forces passing through it are going to meet. So we can say that they have the same line of action, or they act along the same line. So this force is acting along this line, this imaginary line. This force is also acting along the same imaginary line. It's the same way I may have another force here, another force here. Let's say this time it is acting in this direction, right? Then let's say its magnitude is 2 newtons. So for this particular force systems, I have 3 different forces acting along the same line of what action, or along the same line. One, the 5 Newton force, which is acting in the from left to right, that is the direction. It's acting towards the right. Then the 7 Newton force is acting towards the left. The 2 Newton force is acting towards the right. However, the common thing among all these forces is that they are acting along the same line, or the same imaginary line. So we say they have the same line of action. So that is for collinear forces. They have the same line of action, or they act along the same line. The next type we talk about concurrent force system. Concurrent force system. The line of action of the forces when extended passes through a single point. The point is called the point of concurrency. So what are concurrent? So what are concurrent force system then? From the explanation I have here, the lines of action of the forces, when extended, pass through a single point of line, or let's say it passes through a single point. The point which they pass through is called the point of concurrency. Let me create a slide, then I'll use that to explain what the concurrent force system mean. All right, so concurrent force system. So let me get this diagram here. So let's see, I have it says the line of action when extended passes through a single point. Okay, so assume I have one force here. I have a force acting this way, right? I have another force acting this way. I also have another force acting this way. Where are their lines of action? When I take the first force here, I know that its line of action is along its what arrow, which is like this. So that is the line of action of the first force here. Then let me take the second force. Its line of action too is the same thing, is along its arrow. That is for that one. Then let me take the last force. This force, when I extend its line of action, it is also along its arrow. So in these situations, you realize that after extending all these forces, after extending the the line of actions of the forces, they are meeting at a point, right? You realize that they are meeting at a point. So that point, all these forces are meeting here, which is this point, this particular point. That is the point of concurrency. So concurrent force system, their line of action when extended passes through a single point. So the line of action of these forces, when it is extended, when we extend it, and when we extend this one, they meet at a single point. That point that they meet is the point of concurrency. So in other words, if I have, let's say I have two system of forces here. Let's say this is the one force system, force of system, and then this one too is another force system here. You see, when I extend their line of action, their line of action, they are all going through different lines of action. They do not meet. So this force system cannot be a concurrent force system. However, if their lines of actions, when extended, meet at a single point here, which is something like this in this example, then we say that they are concurrent forces, and then they have, that is their point, that's the point of concurrency. So in other words, we can say concurrent forces, they actually, their lines of action converges. Yes. So for concurrent forces, their lines of action, they converge at a single point, right? Then the next example we're talking about is parallel force system. That is, for parallel force systems, their lines of actions do not meet. The lines of actions of parallel force systems do not meet. So in this particular example, this is a very typical example of parallel force system. So this one is concurrent. This one is parallel force system. Parallel force system. Their lines of action, they do not meet. No matter how long I extend these lines of action, they are never going to meet. So parallel force system, their lines of action never meet. Then the next one, we are looking at coplanar force systems. We are saying that their lines of action lies in a single plane. The lines of action of a set of forces lie in a single plane. Then we can refer that force system to be coplanar force system. So let me explain that one too. So we say their lines of action lie in the same plane. So let's say, let me use the Cartesian plane. We know for the Cartesian plane, we have the y-axis, we have the x-axis, right? Okay. But for the purpose of this illustration, let me use just the horizontal axis here. Let me the horizontal axis here. So let's see, this is my axis. Then we are saying coplanar forces, they all act in a single plane, or their lines of action of a set of forces lie in a single plane. So this is the plane. Let me make it even better. So let's say this is the plane. Then what happens is that I have a force acting on this plane. I have another force acting on this plane. I have another force acting on this plane. The direction does not matter. As long as they are acting on the same plane, then we can say they are concurrent force systems. Sorry, coplanar force systems. So when the line of action lie on the single, you see, these lines of action, they are all lying on the same plane. On the same plane. They all lie on the same plane. So as long as they are lying on the same plane, then we say that they are coplanar force system. In another example, let's say I have a plane here, vertical plane, and I have forces acting on it. So if you have more than two forces acting, we say they are it's a force system. We say it is a force system. If it's you have two or more forces acting, it's a force system. If it is one, it's just a single force. Two, they can form a force system. So we have two forces acting on this plane. Then we say that This is a coplanar force system. Why is it a coplanar force system? It is a coplanar system of forces because they all act on the same plane. These forces are acting on the same plane here. Okay, so in some in some complex situations, you may have system of forces, different system of forces acting differently on different material. You may have a system of force that consists of parallel forces, concurrent forces, coplanar forces. I mean, all these kinds of forces, there are some certain instances that you may have concurrent coplanar forces, you may have um, concurrent parallel forces. You not concurrent parallel force. You may have parallel coplanar forces. Yes. So, in summary, we have one. In summary, we have one, the parallel force system, which is represented this way. You have the collinear force system, which is the first force systems, like this. Because in the collinear force system, we are saying that the line of action of the forces are all the same. The forces have the same line of action, and this is how it may look like. Their lines of actions are the same for the collinear force system. Then the second one, which is concurrent force system, the concurrent force system, which is also represented like this. We are saying for the concurrent force system, they have their line of action when extended meet at a common point, which I made it clear that for the concurrent forces we can say they converge. Yes, they converge. So this is how it is all represented. So we have one force here, we have another force here, then we have say the last force here. And then the line of action of this particular force is through the arrow, the first one. For the second one too, the line of action is through the arrow. Then for the third part too, that's where the line of action is. So when we extend the line of action, we realize that they meet at a point here. And that point where they meet is the point of concurrency. The third one is the parallel force system. And we say that for the parallel force system, their line of action do not meet. They do not intersect. Okay. And then for the parallel force system too, we can represent it this way. This one force, this another force. Then we describe their line of action, and we know that the line of action passes through this direction. That it is through the arrow. Alright. Then the last but not the least, we are talking about the coplanar force system. And we say that for the coplanar force system, they all act in the same plane. They are all acting in the same plane. So assuming this is the plane, then we have forces acting on that plane. It should be noted that the force need not to necessarily be perpendicular. We can have forces acting at an angle on the plane. As long as different forces are acting on the same plane, it doesn't matter their direction, whatever. As long as they are acting on the same plane, then we can boldly and confidently say they are coplanar force systems. So we may have one which is very perpendicular, then we may have one to which are inclined at certain angles. And as long as it is acting on the same plane, then we can say it is coplanar force system. All right. Since we said coplanar force system, they act on the same plane, we can also have non-coplanar force system. And for the non-coplanar force system, they are forces that act on different planes. So assuming we had a plane somewhere here, we have one plane here, then let's say we had another plane here, we have another plane here, then there is another plane, let's say somewhere here. Then we have forces acting differently on each of the planes. We have forces acting differently on each of the planes. Then we can say that those forces are non-coplanar. This force, this particular, let me do it this way. So we can say this particular force and this particular force here, they are acting on this particular plane, therefore they are coplanar force system. But this same force here, or this force system, these two force system, and compared to these ones, they are all acting in different planes. So the two of these group of forces, they are non-coplanar because they are acting in different planes. So all these ones, this force system here, in total, in addition, or the collection of these four systems, we say they are non-coplanar because they act in different planes. All right. So we'll be looking at some Newton laws of motion. And the first law of Newton motion, it states that a particle at rest will continue at rest, or a particle with constant velocity will continue to move with the constant velocity unless it is acted upon by an external force. So remember, from the definition of forces, we say it is that which cause something to move when it is which cause something to move, or which cause something which is moving to stop. That is the definition of the force. So in other words, what the first law of Newton's motion is trying to say is that when a particle is at rest, and let's say there is no external force acting on that particle, it will continue to remain in that same position until something causes that object which is at rest to change its position or causes it to move. In the same way, if an object is moving, it will continue to move. It will only come to a halt when something causes the object to change or to come to a state of rest. Okay, a typical example. Let's assume that I have this particular football here. Let's say I have this football here. Then if I leave this football on the table, let me put it that way. I have a football on the table, right? So what it means is that this particular ball will remain on this table. It will continue to remain on the table if no one touches it, or let's say if nothing causes it to move at all, it will continue to be on the table till. However, if I come and pick the ball from that table, it means I have applied a force which has caused the position of the table to change. In that case, there is no, or let's say in that particular instance, then I've caused the relative position of the object to change, which is in relation to the Newton's first law. On the other hand, let's assume I kick the ball. If I kick the ball from the table, it will take a path, or it will move through a path to a different position, or let's say it will continue to move along this path infinitely. Assuming no external force acts on this particular ball, then it is going to continue moving. However, it's not possible in our real life situation because As long as you kick the ball, there are other external forces acting on the ball and they will cause it to come to a halt. Some of the forces include the air resistance and frictional forces due to the ground. So if you kick a ball on the ground, it comes to a halt because there are some kind of air resistance and frictional forces that causes the ball to stop movement eventually. If not the case, the ball might hit something which will cause the ball to stop. So Newton proposed that the first law of motion is a particle at state of rest will remain at rest, or if it is moving with a constant velocity, it will continue to move with that velocity unless it is acted upon by an external force which will change the relative position or the relative motion of that particular object. Now, this law of motion is mostly also referred to as the law of inertia. So the law of inertia or the first law of Newton's motion, they are all the same. Now, the second law of motion, it says that the time rate of change of momentum is directly proportional to the force causing the change, and it takes place in the direction of the applied force. In other words, a particle acted upon by a force will accelerate in the direction of the force. We can also say this is the law of conservation of linear momentum. So let's take, for example, when a ball is on the floor and then you kick the ball, you realize that you are going to cause the ball to move, right? And this movement, it is directed towards the direction that you kick the ball. So let's say if I kick the ball directly towards the goal post, then it means that that is the position is going to take, or that's the path is going to take. So me applying the force in that direction, that is where it is going to go. And we are talking about momentum. You say that momentum, the rate of change of momentum, you see, the ball has a mass which is described as m. That is the mass of the ball. Then this ball, it had an initial velocity. Let's say the initial velocity is represented as u, and it also had a final velocity which is v, right? So the initial momentum of the ball is given as the product of the mass times the u, which is the initial velocity, and then the final momentum is the mass times the v, which gives the final momentum. So the difference in this momentum, that is that change in that momentum, it's giving us the final momentum minus the initial momentum. After we've obtained this, the law says that the time rate of change of momentum, so we have this whole dividing time, that is the rate of change. It says it's that force, this expression should give you a force, and that force is in direct, that force causes the momentum which is in direction of the applied force F here. So in other words, we know that this can also be written as mass bracket v minus u. That is the final velocity minus initial velocity. After factorizing, then we can divide this by t. Now the rate of velocity over time gives us an acceleration. So it means we have mass times acceleration, which is equal to the force. So that's what Newton was saying with relation to the second law. So the force applied is directly proportional to the time rate of change of momentum, and it is in direction of the applied force. So this is that. Or in other words, it says that a particle acted upon by a force will accelerate in the direction of the force. So when I kick a ball, in the previous example, that the ball on the table, if I kick the ball, then the ball will move in the direction that I kicked it. So kicking is the applied force, and it will move towards the direction that I kicked the ball. That is the second law of Newton's motion. Then The third law of Newton's motion states that actions and reactions are equal and opposites. Or let me read what is here. For every action, there is an equal and opposite reaction. Or actions and reactions are equal and opposite. The force of attraction, or let's say interaction, between two particles are equal in magnitude but opposite in direction along the same line of action. For example, let's assume I have yes, for clarity, let's say you realize that when you bang your hand, or when you bang at a table, you feel pain in your hand. So the greater the magnitude of the bang, the higher the pain that you experience. So you banking the table is an action that you are giving, and then the reaction in this regard is the pain that you experience when your hand bangs that table. Another example, let's say if you decide to um, kick, or let's say if you decide to kick a ball with your hand. For volley players, if you decide to kick a ball with your hand, you realize the higher you smash the ball, you are going to feel some pain in your hand. But if you smash the volleyball very relatively small or slowly, let's say very in a small magnitude, that pain that you are going to feel is very small compared to you smashing it higher. So in other words, what I'm trying to say is that for every action that you take, there is an opposite reaction in the same magnitude of action, but then different reaction, or let's say the same magnitude, same reaction in opposite direction. The Newton's third law of motion is mostly used by a typical example is the in the design of the space rockets. Yes, so when it is being started, you realize there's a combustion of the fuel and then the oxygen in there, which propels the rocket to fly into the sky, or to it propels it to move into space. So that is a typical application of the Newton's third law. So as there are huge form, you see the rockets, they have very the fuel that is being burnt is so high that its reaction, or let's say yes, its reaction propels the rocket to move upward. Let me bring it to the lower there for you to understand. Assume you have a Pepsi or Coca-Cola bottle, and that Coca-Cola bottle, you place Mentos in the Coca-Cola bottle. You put the Mentos in the Coca-Cola bottle, then you shake it for some time. You try to open the bottle. You realize that the Coca-Cola inside the bottle will come out with some will be forced to come out, and as it is being forced to come out, it causes the bottle of the Coca-Cola to move in the opposite direction. So assume that this is the Coca-Cola bottle here. This is the Coca-Cola bottle here. I think there's the Coca-Cola bottle here. You filled it with menthol. You started shaking it, and then you finish with the shaking. You open the lid. You realize the Coke inside the bottle will be forced to move outside in this direction. However, the reaction force will cause this bottle itself to move in the opposite direction, which is to say that whilst the fluid flows this way, the bottle is moving the opposite way. That is how the Newton's law of motion can be represented in simple terms. So the action and the reaction, they are equal in magnitude, but opposite in direction along the same line of action. Now let's talk about the law of gravitation. Newton proposed the law of universal gravitation, and it says that assuming we have two bodies or two particles of masses A and B that are separated by a distance r, then the law of gravitation states that the two particles are attracted to each other by a force of magnitude F and act along the line connecting the particles. Let me create another space here. So assuming we have a body here A and then another body here, let's call that one B. So A has a mass MA, B has a mass MB. You realize there's a distance between A and B. Let's represent that distance between them. Let's represent the distance between A and B as R. Now, what the gravitational law is stating is that there exists a force of attraction. There is a force of attraction between this body A and this body B. And that force of attraction, let's assume the force of attraction is represented as F. That force of attraction between A and B is directly proportional to the product of the masses. That is the product of the mass ME, the product of the mass ME times MB, and then inversely proportional to the square of the distance between them. So the distance between them is the R, and then the square of that distance. Now let's change the proportional sign and then represent it with an equation. Then we are going to get F is equal to, since we've changed the sign of proportionality to equal sign, we are going to introduce the constant of proportionality, which is G, then times MA MB over R squared. So this is the general equation for the law of gravitation. The general equation for the law of gravitation. The general equation for the law of gravitation. Okay. So the law of gravitation, Newton's law of gravitation states that the force of attraction F between two bodies MA and MB is directly proportional to the product of their masses MA and MB and inversely proportional to the distance between MA and MB, and that is the square of the distance between MA and MB. The G here is a constant. G is a constant and is the gravitational constant. So the law of gravitation, this is the formula as was derived. This is it. And then the G here, which is the gravitational constant, is given as 6.67 times 10 exponent negative 3. That is the constant, that is the fixed value for that. So it has been determined through experiments. Okay. One thing I also like to say is that this law or this gravitational law was used to derive or was used to determine the acceleration due to gravity, which is g. Why? How was it done? Let's look at something here. We say that the force of attraction is equal to g times ME MB over r squared. Then we also know that, so from this particular equation, let's assume that our ma is equal to the mass of earth. So ma is equal to the mass of earth, which is, let's say, me, the mass of earth. And then our mb here is equal to an object on the surface of the earth. Let's name that one m with no subscript. Then let's say our r here is equal to the radius of the earth. So we name that re as the radius of the earth. Then for the f here, let's assume the f here is equal to the weight of the object which has a mass of m on the surface of the earth. Then we also know that weight is equal to mg. Okay, so doing our substitution, then we are going to get mg is equal to capital G times ma, which is now me, times mb, which is now m, all dividing our re, which is re squared. So we have two masses here and they will cancel out. So our m here will take off our m here. Then we are getting g equal to capital G m e over r e squared. So this particular formula here, it describes the relation between acceleration due to gravity, which is small g, and then the gravitational constant, which is g. Now g is equal to the the gravitational constant here is given, the gravitational constant is given as, let's say its value is 6.67 times 10 exponent -11. And then me here, that is the mass of the earth. Let's say the mass of the earth is 5.9797 times 10 exponent 24. Then we are dividing all this by the radius of the earth. The radius of the earth is also given as 6.37 times 10 times 10 to the power 6, all squared, because the radius is squared. Now after computing this value, we are going to get 9.81344, which is the constant for gravitation. That's the gravitation due to acceleration has a value of 9.81344 meters per second square. So in summary, we say that g is equal to 9.81 meter per second square. So that's how come the g was derived after Newton proposed the gravitational laws, which is stating that the force of attraction between two bodies is proportional to the product of their masses and inversely proportional to the square of the distance between them. Through that, as we know the mass of the earth now, we know the mass of the object on the surface of the earth, then also we know the radius of the earth. Then with the gravitational constant determined, then we can come up with the value for g, which is the acceleration due to gravity, and it is given as the g equal to 9.81. So how g, that is acceleration due to gravity, and then gravitational constants are related, this is how they are related. Or you might also rewrite it to be g r e squared equal to g m e, like that. All right, so that is that for the g. Thank you very much for joining this class, and in the next tutorial I would like to meet you in the next tutorial. And if you enjoyed watching this video, don't forget to like and subscribe to the channel, and then hit on the subscribe button, notification button, so that anytime I upload a video you will get the notification, then the lesson continues with you. Thank you for your time, and I hope to see you in the next video.